All right, so on this part of the video, we're going to kind of wrap up things with some business applications. There's some formulas. I'll kind of tell you what you need to know and what you don't have to know. A cost function is the first thing. Cost function generally has fixed costs and variable costs. We've already talked about that. And you can think of this, if you want to, as mx plus b. Okay, you can use that formula. It's the same as this, basically, though. This is your fixed cost, A, and then BX is your variable cost, like that. Price demand function, X is the number of items that can be sold at a specific price. And if you think about in business, the price that you set on something affects how many things you're going to sell. If you charge too much, people are unlikely to buy something, right? So that's kind of the idea. So that varies. The price will change how many things are bought. All right, revenue, the key thing you need to know is revenue is XP. It's the number of items sold times the price per item. I always kind of explain this way. So, for instance, if you sold, let's say, 8 glasses of soda, and each glass cost 50 cents, well, then what would you do? You do 8 times 0.50, and then that would be the revenue that you bring in, which would be $4. So revenue is just how many things you sell times the price per item of what you're selling. You don't necessarily need to know that formula there. This is what's important, is XP. So really, so far, you want to know this formula and this formula. Price demand functions are generally always going to be given to you in this class. Okay, then on the next page, you definitely want to know that the profit is revenue minus cost. So what you're always doing in a business is this is the money you take in. So that's just the money you get. And then it costs money to run your business, so you just subtract off the cost, and that gives you the profit. All right, so we're going to look at several examples on this. So this example here, I want to go ahead and read that to you first. It says, a company manufactures memory chips for microcomputers. Its marketing research department, using statistical techniques, collected the data shown in the table, where, I don't know, that symbol's wrong. I think that's the wholesale price per chip at which X million chips can be sold. So I think that's supposed to be X there, okay, not that. Okay, then we're going to use regression analysis. An analyst produced the following price demand function. So this is a given price demand function, and then this is a given constraint on that. Okay, I mean, they're not going to worry too much about where that came from. That came from probably a computer program doing a linear regression, which we've learned how to do. So first thing we're going to do is we're going to plot the points, and we're just going to sketch a graph of the price demand function. All right, so we're going to go ahead and do that. We're only going to graph it from 1 to 20. So when you draw your graph, you need to be sure that everything gets labeled. That's an important thing. So you just go ahead and draw out your X and Y axis, and you want to label this like this. This is X. Okay, well, that is million, and label what it is. That's million computer chips. Okay, all right, so we got that. All right, now we're going to go to 20. I'm going to go ahead and start at 0, and we'll just maybe scale this by 5, kind of like that, and then you can estimate the rest like that. And then this is going to be the price in dollars, okay? Now, if you look at your data, the highest data is 72, the lowest is 15. So I think what we'll do is we'll go, let's just go like this. This is 25, this is 50, and that's 75, like that. Okay, and that's probably good enough. All we're going to do is just estimate these points when we do that, though. But be sure you have everything labeled. So this is the point 1. Just go over 1, up about 72, just ballpark estimation. Then we have a point 4, or go over 4, up where you think 63 is. Over 9, up where you think 48 is. And let's see, then we got 14, up about 33. So it seems to be making a pretty good line. And then over 20 and up about 15, like that. So that is what we call a scatter plot of your data, which we've done before. Okay, now what we're going to do is we're going to get the company's revenue function next. Okay, so the revenue is always equal to the number sold times the price. Or in other words, you want to think of it as R of X is equal to X times P. Okay, well, I gave you P. P is given as 75 minus 3X, so we take X, which is the number of computer chips we sell, times 75 minus 3X, that's your price demand function. Now what I'm going to do is just multiply that out. So if I multiply that out, I get R of X equals, and with the distributive property, that's 75X, and then minus 3X to the second. Okay, so that would be your revenue function like that. So if you're given the price demand function, that's all you ever do to do the revenue, is just multiply it by X. Okay, we go to the next page, and let's see. Oh, we're doing the revenue. I was thinking I already had that. Yeah, this is a different table. So, and we'll use the calculator for this to kind of help us with this. So what we're going to do then is just plug into this revenue function. So when we do R of 1, we're just going to plug in here. So that'll be 75 times 1 minus 3 times 1 to the second. So that's 75 minus 3 times 1. So that's 72. So we already got that point right there. Now what I'm going to do on this is I'm going to use my calculator primarily on these things. Well, then we're going to graph that on the calculator in just a minute here. So let's go ahead and just write out what we're going to do on R of 4. On R of 4, we're going to do 75 times 4 minus 3 times 4 to the second. And then again, on this thing, you're just going to go to your calculator when we do this then. So we just go 75 times 4. You do this in one step, minus 3 times 4 to the second. Okay, and we'll record what we get. So the company's revenue is 252. All right. Okay. So now I'm good. So that's 252. Oh, come on. Shoot. There we go. All right, now we're good. Okay, so that's 252. Now the rest of them I'm just going to do like the same way. I'm going to go 75 times 8, and then minus 3 times 8 to the second. It's doing the same thing. Record what we get, so that's 408. Move on to 12, so now we do 75 times 12 minus 3 times 12 to the second. So that will give 468. And we'll keep going with this. We'll go to 16. So now we're going to go 75 times 16 minus 3 times 16 to the second. Okay, so the numbers are starting to go down now. And then we're going to finish up with the 20. So we go 75 times 20 minus 3 times 20 to the second. Okay, and that'll give 300. Okay, now what we're going to do is we're going to graph this on the graphing calculator and get this set up. So what we want to go ahead and do is in your calculator, you want to graph the function. So you want to go to y equals and then put in 75x minus 3x to the second Okay, like that. Then what you want to do is you want to make sure that you get your window set up. Okay, so that would be, what we're going to put there. Now, as far as the window goes, kind of show you what we're going to do on that. So you want to go to your window button. Now, we're supposed to go 1 to 20. If you read the problem, they wanted you to go 1 to 20. I'm going to go 0 to 20, like that, and probably scale that by 5. Now, if you look at your revenue values, the biggest value that I see was 468. So to me, a logical way to scale this is 0 to 500. One too many zeros, okay, and then probably scale by 100. That would, to me, would be a rational way to do that window then. Okay. All right. So now let's do our graph. All right, and then we'll draw a picture of this. So on the graph, what we're going to do is just make an x-axis and a y-axis. And we want to be sure that we label everything. You don't want to be lazy about how you label stuff. That's important. So this is X, and again, this is millions of computer chips. Okay, then this is your revenue. And then make the revenue go up to 500. So 1, 2, 3, 4, 500. Okay, then you can just start plotting these points then. So just kind of get an idea. So we're going to take this out to 20. And you can do like we did on the previous page, just go like that. Okay, then what we can do is just start plotting some points just to get enough accuracy. So we have 1 and 72, again, just sort of ballpark it, get it fairly close, 4, 252, 8 in here somewhere, and about 408, so up there, 12 in here somewhere, 468, 16, 432, okay, not that great. Let's see, 20 and then 300 like that. So that'll give us a pretty reasonably good graph there like that. Okay, so that's what we're going to do with the graphing calculator on that. So that's the revenue function, and notice that revenue has a maximum to it. So that's something in a business you would want to know, is what that maximum revenue is then. Okay, now the next thing we're going to do is we're going to do the profit. So the profit is always equal to the revenue, which we have already figured out, minus the cost. Okay, well, the revenue was 75x minus 3x the second. That's what we just graphed. See, that's right here. That's your revenue. And then the cost is given as 4,000. The 4,000 would be a fixed cost. The 500 would be a variable cost. So we're just going to simplify this expression. And then we got that. Now we want to go ahead and simplify and collect the like terms when we do this then. So this is 75x minus 3x squared. Distribute, so that'll be minus 4,000 minus 500x. And then just put this together. I'm going to write it as, this is the profit function. So we'll write P of x is negative 3x squared. If you do 75 minus 500, see, those are like terms, so that's minus 425x. Then we have minus 4,000 like that. So that would be your profit function. You always do revenue minus cost. So what we're going to do on this is we're going to fill out this profit table now. And we're going to just use the calculator to do this again. And then we'll kind of talk about what the profit looks like on this. All right, so I'm going to write down, a lot of this we're just going to do on the calculator. We already did the 1, so we're going to do the profit at 4. So you would plug into this here, so you would do negative 3 times 4 to the second minus 425 times 4 minus 4,000. So we're going to repeat that for each of these numbers here. So negative 3, you put it in several ways you can put it in. I'm going to just do this like this. Negative 3 times 4 to the second minus 425 times 4, and then minus 4,000. It's okay if you get a negative answer. You can have negative profit. That means you're losing money. So this is negative 5748 like that. Okay? All right, and then we're going to just keep repeating this. We're going to go negative 3 times 8 to the second minus 425 times 8, and then minus 4,000. Okay, so that'll give this. So we still got negative profit here, which we could have. So got that. And then we'll do the 12. So negative 3 times 12. Whoops. Negative 3 times 12 to the second. That's 425 times 12. $4,000. Okay, so still negative. Okay, and then we'll do 2 more. Do the 16. So negative 3 times 16. Okay. And the 20. Okay, so it just keeps getting negative. So it just seems like you're losing more and more money on this situation then. Okay, all right. So what'll happen on this, we're going to go ahead and we're going to put this in. We're going to sketch the graph of the profit and cost function. This may not be the best example on this, but I've got the revenue, and then we have the cost functions a little bit weird on this problem. That's why you're getting all those negative profits and stuff on this. So what we'll do with this then is we'll just put in the negative 3x squared. It could be that this is always more costly. Your cost always exceeds your profit. So we'll answer that question once we get that graph in here. Okay, so I'm going to do window like this. I'm still going to go 0 to 20. That's all I'm interested in. Now this time I'm probably going to need to do some negative numbers. So I'm going to go, let's see, let's go something like negative 15,000. And let's go all the way up to 15,000 just to start. And then maybe scale that by like 500 or something. So let me try this way first. Okay, so it looks like it's just getting a negative profit from then on out like that. So I'm probably not going to bother graphing this thing too much. What'll happen on this, as it looks like, is your window continues to go further and further out. You'll just get into deeper and deeper negative profit on this. So like if I change that to 50, went by a scale of 5, it ain't going to make any difference. It's just going to keep getting further and further down in the red like that. Okay, so let's just kind of sketch a real rough graph of this. Doesn't have to be real accurate on this, so you're just kind of, the profit is always negative. Okay, I wonder on that problem, I may have put a cost function that's not satisfactory on that or something. So I'm kind of thinking on that maybe that value was wrong or something when I typed that out. But it doesn't matter. I mean, you could have something a little bit different than that then. So like, for instance, if I took one of these zeros off here and graph that, you still got negative profit there. If I took and, made this number a little smaller, if I took maybe another 0 off of this, like that, and you're still in the negative profit. Okay, so it just kind of depends on how that cost function and revenue function relate to one another. So that's okay. All right, so let's see. I'll go ahead and close this off, and then that should take care of what I need you to know for this section. Come on, what happened to OneNote? Okay, so that'll be the end of the section.